If we have a power of x equal to a number, we can solve that fairly easily by just taking the reciprocal power of both sides. Okay, by the laws of exponents, x to the 7th to the 1/7 is x to the 7 times 1/7, which is just x. 14 to the 1/7 is 14 to the 1/7. Take that in your calculator. Do 14 y to the x, parentheses 1/7, close your parentheses, hit the enter, or whatever it takes to get this result out of your calculator. Applying the same idea to x to the -4th equals 12, x to the -4th to the -1/4 will give us x to the -4th times -1/4, which is x to the 1, or just x. And on the other side, we're going to get 12 to the -1/4, which we evaluate using a calculator. If we have x to the 3/7 equals some number, in this case 2.8, then we're going to take the 7/3 power, because 3/7 times 7/3 is 1. And the 7/3 power of 2.8 is something that we again evaluate using a calculator. If we have this equation, well, we're going to multiply by the common denominator before we even start thinking. Get rid of the denominators. Of course, that's going to exclude the value x equals 0 from our solution, but that's not going to be a problem because x equals 0 is not going to be a solution. Okay, so we multiply both sides by x to the -2/5. Of course, times 0 just gives us 0, so we don't write it down over here. Distribute through, and this equation is easily rearranged into this form. We subtract 3 from both sides, change the signs, we get 4x to the -2/5 equals 3, and then we divide both sides by 4, so we get x to the -2/5 equals 3/4, and then we use the same techniques. We're going to take the -5/2 power of both sides. Looking at systems of equations, we're not going to do the linear systems. We've done enough of those that everybody should know how to solve a linear system. But this system here, ab to the 7th equals 9, ab to the 3rd equals 12, which is typical of something you get if you're trying to do a two-point model for an exponential function. Now, there are different things we can do. We could actually take the log of both sides here and get rid of our exponents and do a solution, but that would be a lot more complicated in this case than what we need. We usually don't use a log of both sides unless the variable that we're looking for is in an exponent and stuck up there, and we've got to get it out of the exponent. Okay, so what we're going to do here, there are two alternatives. We could solve, say, this equation for a and then substitute for a down here, or we could solve this equation for b if we wish and substitute for b here. That's one alternative. Either solve for one variable or the other and substitute in the other equation and proceed as usual. But we're going to be a little trickier here. We're going to divide the first equation by the second in this case. That's going to have the effect of getting rid of the a, because this side divided by this side is here, ab to the 7th over ab cubed. The a's cancel, and we get b to the 4th. 9 over 12 is just 9 over 12, so we have b to the 4th equals 9 over 12. Taking the 1/4 power both sides, we get b equals 9/12 to the 1/4. Of course, 9/12 is 3/4, but we're not worrying about that right now because we're going to evaluate this thing on a calculator anyway. Okay, well, let's go back here a minute just to see where we're going. Now that we've got our value b, we take it back and substitute it for a here, and that gives us, it brings us around and gives us this equation here. A times 9/12 to the 1/4 to the 7th equals 9. Now, there's a lot of simplification we could do here. That's a 3/4, that's a 7/4 power. I probably should have reduced this down to 3/4 by now, but I didn't. A times 9/12 to the 7/4 is 9, so A equals 9 over 9/12 to the 7/4. We can evaluate this using a calculator, and now we have our solution, our A and B. Our alternative would have been, of course, to solve the first equation for A. We would have obtained A equals 9 over B to the 7th. Substitute that back here. We get 9 over B to the 7th times B cubed equals 12. 9B to the -4th equals 12. And we're back just about to where we were before. So we get our value for B, which is again going to be 9/12 to the 1/4. Substitute it, our value for A I guess there's something wrong down here, but you can work out the arithmetic of it.